Hello! So it looks like we're on lesson 2.1.3, problem 2 tac 29, because I think we just did 2 tac 28 last time. So let's look at 2 tac 29. It says, after solving for x in each of the diagrams in problem 2 tac 28, Jerome thinks he sees a pattern. Well, I hope so, Jerome. He notices that the measure of an exterior angle, the angle formed by extending a side of a triangle, is related to two of the angles of the triangle. So here we've got the exterior angle x and the two interior angles A, B, and the third one C, right across from x. It says, do you see a pattern? Study the results of problem 2 tac 28 to help. Well, yeah, we see a pattern because didn't we already look up the exterior angle theorem? Which is like, where is it? Exterior angle theorem. Come on, Jerome. Exterior angle theorem, here we go. States that the measure of an exterior angle of a triangle is greater than either of the measures of the remote interior angles. Where is it? Right here. Yeah, so we already knew that. It's not just greater, it's actually equal to this one, D. Alright, but maybe they want us to show it. So it says, do you see a pattern? Yes, we do. In the example at right, angles A and B are called remote interior angles of the given exterior angle because they are not adjacent to the exterior angle. Right? So C is adjacent to X, so A and B are the remote interior angles. Write a conjecture about the relationship between the measures of the remote interior and the exterior angles of a triangle. So write a conjecture and then prove it. Okay. Alright. So let's go ahead and prove it. So let's write the conjecture, I guess, first. So we kind of suspect that x is maybe equal to a and b, but let's go ahead and see if we can prove it. So we know, let's see what we know here. We know that, how do I insert my equation? We know that a plus, let's just write it this way, a plus b plus c equals 180, right? That's one of the things that we know. Okay. So that just states that the interior angles of the triangle have to add up to 180 degrees. We also know that because x and c are on a line, right, that x plus c are supplementary angles, so they have to add up to 180. Interesting. All right, so we have a system of equations here. So let's go ahead and put this equation right here in terms of c. So let's go ahead and say that, let's see. Well, actually, we don't even have to do that. We could actually just set these two equal because we both know that they're equal to 180. So let's do that instead. So now we know, because this has to add up to, these three have to add up to 180, and these have to add up to 180. We can just set these to be equal. So that means that a plus b plus c equals x plus c. Okay? Because this is equal to 180, this is equal to 180, so this must equal this. So a plus b plus c, so the sum of all the interior angles has to equal the sum of these two. Okay? Well, actually, look at this. We've got a c on both sides. So actually, we can just subtract c from this side and subtract c from this side. And those are going to cancel. And those are going to cancel. And look at that. We have the remote exterior angle theorem, or the exterior angle remote interior theorem? I forget. Anyways, we know that the exterior angle, x, is equal to the sum a plus b. Boom. Done. Come on, Jerome, get with it. Alright, now we've proved this relationship. Add this theorem to your theorem graphic organizer. I didn't know that we had a theorem graphic organizer. I guess we're supposed to have one. Anyways, let's go ahead and add it. Alright, let's move to the next problem.